Hi, my name is Matthias Beckert, and today I would like to introduce you to the application development workflow of our new Linux for Safety Applications SDK. So let's dive directly into it. And our workflow is primarily constructed around CMake. So what is CMake? CMake is a cross-platform free and open source software for build automation. So what you can do with it? Well, the core features are that you can build multiple platforms from a single source, and it accurately tracks all your dependencies inside your build. Also, it allows you to build out of your source tree for better organization. And another very cool thing is that it supports toolchain files. Those toolchain files are very, very powerful. In addition to toolchain files, we also have stuff like presets and also a lot of other cool stuff. On the right side here, you can see really the minimum example for a CMake-based project, where you have your C++ implementation of a main function and the corresponding CMake code that would build this application for your requested platform. I already mentioned toolchain files, and toolchain files are very powerful because they allow you to bundle a set of configurations like compiler flags for your platform you would like to build for. So usually if you would like to build for a Linux, then you have a toolchain file. If you would like to a different processor architecture, but still for the same Linux, well, then most likely only the referenced compiler will change in this toolchain file. And for every environment you can think of, you can construct a toolchain file. And these toolchain files allow you also to abstract stuff like include folders or library folders, which might be specific to the used sysroot you're referencing. So if we have a quick look onto CMake, how you could build a project either for x86 or for AArch64, it would really look like this. You have a CMake call where you reference with -s your current source folder, with -b you would reference the location of the build folder, and with -d CMake toolchain file you would reference the currently used toolchain file for the environment you would like to build for. Then you can simply call the --build command with referencing your build folder, and you can also call the install command, which will then trigger the installation process, which in the end will construct either a small sysroot of the installed files, or on a more generic setup, you would directly install into your current root file system. For cross-building, we usually would like to install into an existing sysroot or into a separate sysroot only for this application. So let's have a quick look how this looks like if we really want to compile an application that has been modeled around CMake as a build infrastructure. What you can see now is the opened workspace of the corbos Linux for Safety Applications SDK. And this SDK comes with also some example applications. You can see one here on the screen. It's a simple test program that simply parses some JSON input and then prints it out. It is located under apps My JSON app. And if we would now like to build it, first of all, we need a sysroot where you can compile against. How to build a sysroot is something you have already learned in our image building session. So how can we now use this? We can simply reference it by a toolchain file, which is already part of the SDK. So let's create make dir build x86, oh, not XA, x86, and also make dir build AArch64. So we now have in this application two subfolders. We also can see it here, and these subfolders will now host all our build files. So how we can use them now? Well, it's fairly simple. First of all, we type in CMake. We say as source folder, this is our current directory. This is something which wouldn't be needed explicitly, but I would like to include it here because it was also shown on the slides. Then what shall be our build directory? The build directory is /build x86. And now we need the corresponding CMake toolchain file. So we specify it with -d CMake toolchain file equal, and now the location of the file, which is /build/CMake toolchain file x86-64 CMake. Now we press enter. CMake configures our build directory. This can also be seen here because now the directory has some input while the AH64 directory is still empty. And if we would now like to build it, we can simply call CMake --build and reference the build folder that we are currently using. And now the application is built. In order to do the same for AH64, the only thing we need to do is we need to tell the system, please use the AH64 build folder and also use the correct toolchain file, which is ah64.cmake. Now we also have configured that folder, and we can again call the build command, but now for the different build folder. And as you can see, I have built 2 applications now, and let's quickly double check with the file command the type of this application. So build x86, we have the my.json app binary here, and file tells us here it's an executable and it's 64-bit x86. And if we do the same for the created file in our AH64 folder, we see again it's an executable 64-bit, but this time for the ARM architecture. And with that, now back to the slides. You have seen now that CMake allows you to hand over a lot of different arguments to your CMake call, like the toolchain file you would like to use, or also the build folder you would like to build in. And while it is nice that you can specify this all manually, it would be much nicer if you could have a more elegant way of handing over all these arguments. And this way exists, and it is called CMake presets. Presets allow you to specify toolchain files, environment variables, or also CMake variables for a certain preset. And the preset itself, they are specified as a JSON format, which allows you to inherit existing presets or also include existing preset files. And on top of that, CMake is integrated very well in VS Code, so that you can really have the full experience there. Here on the right, you now see an minimalistic preset file, which first of all defines the version of CMake that you need to use it. And also it shows you that you include a different preset file, which may already provide some set of base functionality. Now we specify a configuration preset, which provides us the information of the destination dir we would like to install later and also the directory that we would like to build in. Then we have a generic QEMU x86 preset, which inherits all the other stuff from the previously explained configuration preset and in addition specifies the toolchain file. And on top of that, we also have a so-called build preset. The build preset also references the configuration preset and itself defines the default target when calling build. And for this, the default target would be installed. So when we call build, we also directly install into our temporary installation directory, which we defined with the dest dir environment variable before. Also, you can see here with jobs set to 8 that CMake would try to parallelize the build as well. Having said that, let's have a look how this looks and feels when we use it with our Linux for Safety Applications SDK. Okay, again, we are in our corbos Linux for Safety Applications workspace of the SDK. And what you can see here is, again, the my.json, which we again use as an example also for the preset-based CMake integration. Speaking about presets, let's have a look at the CMake preset file, which is at the top level of the application folder. Inside this preset folder, we see here that we include a generic corbos Linux preset, which, for example, defines the different toolchain files for x86 and AH64. Additionally, we also have configuration presets and build presets for the different architectures like QEMU x86, QEMU AH64, and hardware, where we reference AH64 as the architecture for our hardware. Okay, in order to use this together with the VS Code CMake integration, it is pretty simple. The only thing you need to do is you select down here on the bottom ribbon the active folder, therefore the active application. And this is, in our case now, the my.json app. And what we also can do is we can select here the preset we would like to use, as they were listed in the JSON file before. So we now take the x86 preset, for which we need a sysroot, obviously, but how to build a sysroot is something that has been shown to you in the image building session of this video series. So this is simply referenced now by the toolchain file, which is connected to this preset. And when I now press build, everything is built. And we see here that there is an application placed in this folder. And if we now check what type of file that is, we can simply type in file. We paste the file here, and we see here it's an executable 64-bit and x86 64. We can do the same for also the QEMU AH64 preset. Let's select this one, click on build. Again, the same output, the same build output. Now we click this file, this path here, we copy it. We go to the terminal and type in file again, but this time for AH64 and not for x86. We press enter, and we now see here it's again an executable for 64-bit, but this time for AH64. And this brings us to the end of this session about the CMake-based application development. Thank you for your attention, and stay tuned for part 2, where I will give you an overview on the application deployment and debugging on a running target. Bye.